Hello friends, today we discuss on complementary function, which is the part of linear differential equation. So see that complementary function is the part of general solution of linear differential equation, and also particular integral is the second part. Today we discuss only for complementary function. See that complementary function is depends on the roots of auxiliary equation. See that auxiliary equation is denoted by phi of d is equal to 0. And it's depending upon its roots. There are four parts of complementary function. So see that which four parts. Number one, if roots of phi of d is equal to 0 are real and distinct, right? So we call it as a or say it as a m1, m2, m3 up to mn. There are n roots because the order of our linear differential equation is n. Then complementary function, we write it as a yc. Then the roots are c1 e raised to m1x plus c2 e raised to m2x plus c3 e raised to m3x plus and so on cn e raised to mn. See that roots in coefficient of x, m1, m2, m3, mn, all are interchangeable. Then second case is, see that roots of phi of d, that is auxiliary equation, are real and repeated. Say it is as m1 is equal to m2. So that only two roots are equal. Remaining roots m3 to mn again real and distinct. Then its complementary function is yc is equal to c1x plus c2 e raised to m1x or m2x, both are equal, plus next c3 e raised to m3x up to cn e raised to mnx, again case for real and distinct. Then if, see that if roots m1 is equal to m2 is equal to m3, if three roots are equal and remaining next root, which root, m4 to mn, again real and distinct. So three roots are equal, then its complementary function, see that yc is equal to c1x square plus c2x plus c3 into e raised to m1 or m2 or m3 plus for c4 e raised to m4x to cn e raised to mnx. This case is for real and distinct. Okay, this is the case number 2 for real and repeated. Now third case is for, see that third case is for, so that roots of phi of d is equal to 0 are imaginary and distinct. We say it is, so that m1, that is first root is alpha plus I beta, where alpha and beta are real numbers and I is the root of -1. Then m2 is obviously alpha minus I beta, means imaginary roots always in pair of conjugates, alpha plus I beta, alpha minus I beta for all imaginary roots. Then its complementary function, see that e raised to alpha x, see that this alpha is there, into bracket c1 cos beta x plus c2 sin beta x. This beta is imaginary part of these complex numbers. That is our case number 3. Now the last one, case number 4. Number 4 case, roots of phi of d is equal to 0 are imaginary and repeated. We say it is first root m1 is equal to alpha plus I beta, m2 is equal to alpha minus I beta. This is the pair of conjugates. Then third one is m3 is equal to alpha plus I beta. Again m4 is alpha minus I beta, because we get imaginary roots in pairs, so we get two pairs and both pairs are equal. Then its complementary function, see that yc is equal to e raised to alpha x. Alpha is common for all four roots and beta is also common, and that written as c1x plus c2 cos of beta x plus c3x plus c4 sin of beta x. See that are four parts of complementary function depending upon its roots. First is real and distinct, second one is real and repeated, third one is imaginary and distinct, and last one is imaginary and equal. Now we see its counter examples. See that first one, solve d2y by dx square minus 5 dy by dx plus 6y is equal to 0. Then see that we can write it as a d square minus 5d plus 6 into y is equal to 0. Here our d stands for d by dx. Then see that auxiliary equation d square minus 5d plus 6 is equal to 0. Then its roots factors are, so that d minus 2, d minus 3 is equal to 0. Then roots are d is equal to 2 and 3. See that this 2 and 3 both are real numbers and also distinct. Then we use case number 1 for it. And the case number 1 is like that: c1 e raised to 2x, 2 is our first root, plus c2 e raised to 3x, and 2 and 3 are interchangeable. So that be the complementary function for this first example. Now next one, number 2, solve d2y by dx square minus 6 dy by dx plus 9y is equal to 0. Then again we write it as a d square minus 6d plus 9 into y is equal to 0. Then auxiliary equation is d square minus 6d plus 9 is equal to 0. Then it can be written as that d minus 3 is equal to 0. Then roots are 3, 3. See that this is a real numbers, but it is repeated, so we have to use case number 2. So using the formula of case number 2, then complementary function is, see that yc is equal to c1x plus c2 e raised to 3x. Right? Now see the next example. Solve d2y by dx square plus 2 dy by dx plus 2y is equal to 0. Then we can written it as d square plus 2d plus 2 of y is equal to 0. Then auxiliary equation auxiliary equation is d square plus 2d plus 2 is equal to 0. Now see that for this quadratic equation there is no real roots, then we have to find its roots by the way, you know the formula. For finding roots, see that d, the roots are minus b plus minus root of b square minus 4ac upon 2a. This is the formula for finding roots. So our equation is d square plus 2d plus 2. So our a is 1, b is 2 and c is again 2. After putting this, we get d is equal to minus 2 plus minus b square, that is 2 square is 4, minus 2 into 2 into 1 become 4 into 2 into 1 become 8 upon 2 into 1 become 2, right? Then by solving this we get minus 2 plus minus root of minus 4 upon 2. So minus 2 as it is plus minus root of minus 4 means we can write it as a root 4 and root of minus 1. So I write this root of minus 1 root of 4 upon 2. So you know the value of root of minus 1, which is I. Then minus 2 plus minus I into and root of 4 become 2 upon 2. So after dividing by 2 we get minus 1 plus minus I. See that this is imaginary roots where alpha is minus 1 and beta is 1. So we compare it as with our formula. The formula is alpha plus minus I beta. It is the imaginary roots. Then we write as alpha is 1, alpha is minus 1 and beta is 1. Then our complementary function yc is equal to e raised to minus 1 x into bracket c1 cos of x plus c2 sin of x be the complementary function for imaginary roots. Now see the next example number 4. Solve d raised to 4y upon dx raised to 4 plus 8 d2y by dx square plus 16y is equal to 0. Then we write in form d raised to 4 plus 8 d square plus 16 of y is equal to 0. Then its auxiliary equation is auxiliary equation is d raised to 4 plus 8d square plus 16 is equal to 0. Then we write it as a d square plus 4 bracket square is equal to 0. Then you know that the roots of d square plus 4. So d square plus 4, I write first it as a d square plus 4 is equal to 0. Now the roots of d square, or write as a d square plus 4 is equal to 0 or d square plus 4 is equal to 0. Then roots are d is equal to plus minus 2i. For this, again for this plus minus 2i. So we get total 4 roots. So first is plus 2i minus 2i, third one is plus 2i, again fourth one is minus 2i, and that all roots are imaginary and also repeated. See that pair is repeated. The first pair is plus 2i minus 2i, pair of conjugate, again plus 2i minus 2i, pair of conjugate. So we have to use case number 4 for this. So for that we write just 0 plus minus 2i and 0 plus minus 2i. By comparing with that formula, our alpha is 0 and beta is 2. Now then our complementary function, see that e raised to 0x, 0 is our alpha, then into bracket c1x plus c2 cos of 2x plus c3x plus c4 sin of 2x. So these are 4 examples depending upon types of complementary function. So we take 4 examples. Then see one more example. I take number 5. Solve d cube y by dx cube minus 6 d2y by dx square plus 11 dy by dx minus 6y is equal to 0. Then we write that equation as a d cube minus 6d square plus 11d minus 6 of y is equal to 0. Then its auxiliary equation is d cube minus 6d square plus 11d minus 6 is equal to 0. Then its roots are d is equal to 1 1 1. We get 3 roots. All 3 roots are roots are 1 2 3. We get 3 roots. All 3 roots are distinct roots. So the complementary function is c1 e raised to 1x plus c2 e raised to 2x plus c3 e raised to 3x. This will be the complementary function for this. Then next I take again one example. Solve d cube y by dx cube minus 3 d2y by dx square plus 3 dy by dx minus y is equal to 0. Then we write that linear differential equation this way: d cube minus 3d square plus 3d minus 1 of y is equal to 0. Again its auxiliary equation is d cube minus 3d square plus 3d minus 1 is equal to 0. Its roots are 1 1 1. Then see that this all 3 roots are real and repeated. So using case number 2 for it, case number 2 of complementary function, that is this: yc is equal to c1x square plus c2x plus c3 into e raised to 1x, that is e raised to x. So again I take next one. Solve d2y by dx square plus 9y is equal to 0. This differential equation written as d square plus 9 of y is equal to 0. Then its auxiliary equation is d square plus 9 is equal to 0. By finding its roots, we get d is equal to plus 3i minus 3i. So that these roots are imaginary and also distinct. So we have to use case number 3 for it. So in case number 3, our roots is of the type alpha plus I beta and alpha minus I beta. So comparing with this, we get alpha is 0 and beta is 3. Then our complementary function is e raised to 0x for alpha into bracket c1 cos of 3x plus c2 sin of 3x. Again, you know that e raised to 0x is 1, so we will only write c1 cos of 3x plus c2 sin of 3x be the complementary function for this. Thank you.